Inequalities. Let's jump right in. It's more review. Essential question. How do I solve linear inequalities and represent their solution set on a number line? That's right. Today we're drawing things on a number line. The artists in you will be pleased. First example. I want to solve this equation and graph the solution set on a number line. Now, the solving today is not going to be an issue. I'm going to fly through it and focus more on the number line part. So let's start off. In this equation, let's kill the parentheses by distributing in. That gives me 2x minus 8 is greater than 4x plus 6. I didn't mention this, but you might remember it. Whenever you're solving an inequality, you basically treat the inequality just like it's an equal sign. All of the other rules about equations will apply. So whatever I do to one side, I have to do to the other side. With that in mind, let's get all the x's on the same side by subtracting the 4x over. Cancels here, negative 2x here. Also, let's put all the numbers on the other side. So I'm going to add 8 to cancel it off this side. Add it to the other side, so I'm left with 14. It's really important to copy your work because this greater than sign, I need to keep in mind that it's a greater than sign. At this point, I have a negative 2 to cancel from in front of the x. I'm dividing by negative 2, so I have x is greater than negative 7. But don't write this greater than down just yet because there's something I need to do. Remember, if I at any point divide by a negative when I'm doing an inequality, what needs to happen here? I need to switch the direction. So instead of greater than, it becomes less than. So I have x is less than 7. That's my final answer. Finally, I need to graph this solution set on a number line. So let's draw the number line. I'm not going to care about putting too many numbers on. Obviously, I need negative 7. Let's just put negative 6 over here and negative 8 over here. We need to think about what it means for x to be less than negative 7. Could x be negative 7? No, because I don't have an equal sign below the less than sign. So that means that around 7, I need to put an open dot. The open dot indicates that x cannot equal negative 7, but it can get really close to negative 7. Then I need to think, are the values of x that are less than negative 7, do those live to the left of negative 7 over this way? Or do they live to the right of negative 7 over this way? And obviously, if you're thinking about x's and how it relates to negative 7, less than means that you need to go to the left. So let's draw a nice arrow coming off to the left of my open dot. Any inequalities to the left are ones that work. And that's my final answer. Next problem. Sometimes you will see problems that I like to call in-betweeners. We have a situation here where I'm reading negative 3 is less than or equal to 4 minus 1/2 x is less than or equal to 3. So there are 3 parts to this equation. Basically, they're telling me that the 4 minus 1/2 x is in between the negative 3 and the 3. To solve these, there's a very easy trick. You think of it like a 3-sided equation. So let me recopy it real quick. Since it's a 3-sided equation, whatever I do to the middle, I need to do to all 3 sides. So I'm still trying to isolate this x. But now instead of isolating it on one side, I need to isolate it on the middle. Just in your mind, cover up the negative 3 over here and the 3 over here. Don't think about those. Just worry about the middle and think about what do I need to do to cancel to get the x by itself. In this case, you should be thinking, hey, I need to subtract 4, then I'm going to have to get rid of the negative 1/2. Subtracting 4 cancels it from here, but remember I need to do it to all 3 sides. So on the far left, I have negative 7. Less than or equal to, I'm left with negative 1/2 x, less than or equal to negative 1. Now I need to cancel the negative 1/2 from the middle. Remember, we're still focusing in there, trying to get x by itself. To cancel the negative 1/2, I need to multiply by negative 2. That's the reciprocal, right? Negative 2 over 1 is the reciprocal of negative 1/2. These cancel. I also need to multiply the negative 7 by negative 2. I also need to multiply the negative 1 by negative 2. And you should be thinking to yourself, flip the direction of the arrows or the inequalities because I multiplied or divided by a negative number. So negative 7 times negative 2 is 14. I'm left with just x in the middle. Negative 1 times negative 2 is 2. And I flipped the directions of my sign. Here's my final answer. And basically what it means is that x is in between 14 and 2. Here's how we're going to represent that on a number line. Think about it. This is an in-between problem. So the answers are going to be all the numbers in between 14 and 2. So what numbers for x work? Let's think. Well, at the top, 14 works, right? 13 would work, 12 would work, 11 would work, and so on until I get down to 3 and 2 at the bottom. Going any lower than 2 though, and it wouldn't be bigger than 2, which is what I need. So in between 14 and 2 work. Let's write that on our number line. Here's 2, here's 14. Since 2 and 14 do work, because there's an equality sign, I'm going to use a closed dot. And then I'm going to shade everything in between because all the numbers in between work. Final answer. Example number 3, sometimes you'll see the word or. So for this problem, it says solve x minus 4 less than or equal to negative 6 or x plus 2 greater than 5. I'm going to solve each of these separate equations separately. And they're very easy equations. So in this guy, I just need to add 4 to both sides, right? So adding 4, let's see, plus 4, plus 4, I have x is less than or equal to negative 2. Or, let's solve the other one. Over this one, I would need to subtract 2, so I have x is greater than 3. Now, that's my final answer. That was easy. Let's think about what this means for my solutions. If x is less than negative 2, it's a solution. So let's think about some numbers that are less than or equal to negative 2. I could do negative 5, negative 4, negative 2 would work. As long as I go above negative 2, though, it doesn't work. Also, because of the or, numbers that are bigger than 3 also work. So not 3, but 4, 5, 6, and so on. Those answers also work. These are answers in my solution set. So on my number line, basically what's happening here is I have 2 separate arrows going on the same number line. Negative 2 down here is kind of critical, right? We said that it could be negative 2, so use a solid dot, and then numbers below that work. Now, numbers in the middle don't really work, but once I get up to 3, numbers higher than 3 do work. So I'll draw my arrow going this way. I'm going to use an open dot at 3 because it's just greater than, there's no equal sign there. And that's my final picture. Either the numbers below negative 2 work or equal to negative 2, or the numbers above 3 work. Okay, one last example, and this will be a quick one. Here they're telling us what the solution is. They have given us a picture of the solution, and they want us to write basically what the math version of that solution is. So I need to take this picture and turn it into some sort of expression. So you should recognize each of these situations as one that we just talked about. A, if you look at the picture, is an in-between problem. So my answer, my expression that I'm trying to write, is going to look something like this. Part B is an or problem, right? I have 2 arrows going in separate directions, so part B answer is going to look something like this. So let's worry about part A now. I know that it is an in-betweener, and so I just need to figure out what numbers does x lie in between. Well, clearly I have -3 at the bottom. I have 1 up at the top. I need both of my inequalities to go in the same direction. That's a feature of in-betweeners. The inequalities always go in the same direction. And x needs to be bigger than -3. It needs to be less than or equal to 1. I chose the equal to because here's a closed dot. And this should make sense, right? X is bigger than -3, right? I'm shading to the left of -3. But over here, x is smaller than 1 because I'm not shading past 1. So this is my final answer. For letter B now, I have an or situation, so let's just write the word or in the middle. And you can kind of just think about these two arrows separately. Down in the left-hand arrow, it looks like x is less than -1 because the arrow is going to the left. And I chose less than, not less than or equal to because of the open dot. On the right, I have x greater than or equal to 1 because, well, it's going to the right, so I chose greater than. I chose the equal to because of the open dot. Here's my final answer. Just a quick summary, in inequalities, when you divide or multiply by a negative, that makes you switch the direction of the inequality. So a greater than would become a less than. You need to use an open dot for greater than or less than. You need to use a closed dot for greater than or equal to, or less than or equal to.